Hello friends, welcome to my channel. Here I solve LeetCode problems and prepare to the code interview. Today's problem number is 2147, number of ways to divide a long corridor. Along a long library corridor, there is a line of seats and decorative plants. You are given a zero-index string corridor of length n, consisting of letters S and P, where each S represents a seat and each P represents a plant. One room divider has already been installed to the left of the index 0 and another to the right of the index n-1. Additional room dividers can be installed for each position between indices i-1 and I, from 1 to n-1. At most one divider can be installed. Divide the corridor into non-overlapping sections where each section has exactly 2 seats with any number of plants. There may be multiple ways to perform the division. Two ways are different if there is a position with a room divider installed in the first way out, but not in the second way. Return the number of ways to divide the corridor. Since the answer may be very large, return in modular 10 power 9 plus 7. If there is no way, return 0. Let's solve it. First of all, let's define some edge cases. For instance, in the example 3, you can see if we have only one seat, there is no way to build any section. So in case we have less than 2 seats, we can return 0. So it can be 0 seats, 1 seats. Else, if we have only 2 seats in whole corridor, we can also return 1 because by definition we must have 2 seats in each section. If we have only 2 seats, so we can return 1 because there is only one possible solution. Else, if there are 3 or 5 and any odd number of seats, there is no way to solve it, because after we placed all after we place all dividers, uh, the rest one seats can be invalid. So in this case, we have odd number of seats. We also should return 0. So uh, there are base cases. Now let's check our ordinary cases. You can see so because we must have 2 seats in each section, so we can place divider in any place between plants, between each group of 2 seats. So if we have any number of plants before first group, for instance, uh, like in example 1, in case we have some plants before first two groups, we shouldn't consider it. So we should count only plants between uh, groups of two seeds. So in the example 1, it's plants at index 2 and 3, and we don't consider plants at index 5 because these plants are between two seeds. So we don't consider plants between a pair of seeds. So to build a solution, we need to multiply number of ways to place divider uh, between each group of two seeds. So if we have two plants between group of two seeds, we have three ways to place divider. If we have another, for instance, one plant means we have two ways to place a divider between this plant or after it. So in case we have two plants between one group of two seeds and one plant somewhere after, the total number of solutions is multiply 3 and 2, so total result is 6. So let's do it in the code. First of all, we need to count how many seeds we have. To do it, we can use a loop, but because we will solve it in Python, we have a use a function counter. So let's define a variable counts and use function counter with one with argument corridor. So we will get a dictionary with two keys P and S and values, then number of seeds and plants. So let's define base cases. If counts of S equals to 2, in this case return 1 because we have only one solution. If this number is 0 or counts of S is odd, so modulo 2 equals 1, in this case return 0 because we don't have any solution. After it, let's define a main logic. First of all, we need to count current number of seeds and plants. By default, both are 0. And also we need to define some variable for result. And it's 1 by default because we will multiply the number of plants between each group of two seeds. In return, result modulo 10 with value. And add a loop for each character character in corridor, and if C equals to S, so it's seat, increment current number of seats, and otherwise elif. Now let's count number of plants between group of two seats. First of all, first uh, first plants we need to count should be after first seat. So we must have s greater than 0, and else s should be even. So modulo 2 is 0 equals 0. In this case, increment p by 1. Else, let's return to the first condition, and if p greater than 0, so it will be if we meet another seat after some count of plants between group of two seats. And in this case, let's multiply it to result, so it's p plus 1. And don't forget to reset p, because after we consider uh, count of plants, we need to reset it and wait after we finished another pair of seats. It's almost all solution. Last thing, we need to consider and avoid plants at the end of corridor. To do it, we need to check if current number of seats equals to total number of seats. In this case, all items after it is it's plants we don't need to count. So in this case, just break. That's it. Let's check the tests. Something wrong? Yeah. We counts, not count. Counts, this counts. Let's check again. And one more counts. Check again. Test passed. Let's submit it. It works. It's quite efficient. And last thing, let's analyze the time complexity of our algorithm. First thing, when we count number of seeds and plants, we use function counter that has time complexity of n, because it can be replaced with a single loop. After it, we use loop for all characters, so it's also O of n, so total time complexity is O of n. It's quite effective and optimal. That's it for today. We have solved hard level problem, but I think it's more medium level problem because it's not so difficult. Thanks for watching. See you tomorrow. Bye.